Hello, I am Nostradamus. Welcome. In this presentation, I'm going to talk about changes in the sun's behaviour and how it can affect the climate here on Earth. Most people are familiar with the relationship between solar activity and the Earth's climate. During prolonged periods of low solar activity in the past, known as grand solar minima, where the sun exhibits hardly any sunspots at all, it has been observed that the average global temperature has dropped dramatically. It is widely believed that this is due to changes in the amount of direct radiation that the Earth receives from the sun, but I disagree. I believe a more complicated process is at work involving the methane molecule. I shall now endeavour to explain and prove my theory in the rest of this video. Since the beginning of March last year, 2019, I've been recording down the atmospheric methane concentration levels at 931, 706, 477 and 300 millibars on a weekly basis. I've been taking my figures from the NOAA infrared atmospheric sounding interferometer site, and it gives you all the details of what the methane concentration is at all the different levels in the atmosphere. Having collected the 16 numerical sets of data each week, I work out an average, and I take the averages, and from those averages I work out a further average of a 3-week rolling average, and it gives a nice smooth graph. This is the mean methane concentration up to an altitude of 300 millibars for the past 12 months up to the very latest data. Methane in the atmosphere is subject to seasonal variation. We always have a small peak in the spring, followed by a larger peak round about this time of year, actually. And I thought we'd reached our peak about three weeks ago, and it was starting to fall back down, but there's just signs of a little uptick. Right, for the rest of this video, I'm going to be just talking about comparisons between this year 2020 and last year 2019. What I've done here, I've brought down all the figures from 2019 and placed them next to this year's figures, 2020, with the corresponding week to week. So it's the same time of the year. And as you can see, this year's methane levels have been tracking higher than last year's concentrations in the atmosphere. This graph is showing from mid-March up until the present day, the last week in October. So what this graph is showing is the deviation this year from last year. So we started off in mid-May, where the concentrations were about 12 parts per billion higher this year than they were in mid-May, the same time last year, 2019. The difference between this year and last increased up to almost 13.5 parts per billion during April, and then during May, the difference between this year and last year dropped dramatically down to just 8 parts per billion, and it's been steadily increasing since then up to now. The very latest figure for last week, and keep bearing in mind I'm using averages, is we're at 11.7 parts per billion higher concentrations than we were in the last week of October 2019. However, because I'm using averages, this won't show up on the graph yet. On the 24th of October, a couple of days ago, I averaged out the numbers to be 1,867.4 parts per billion. On the 26th of October last year, 2019, we was at just 1,852.6 parts per billion. So on actual data figures, it's showing that we're almost 15 parts per billion higher than at this point in time last year. But there is a lot of variation. But I'll be coming back to this a little later. So what's all this got to do with solar activity, you may ask? I'm over here on the NOAA Space Weather Prediction Centre website. I'm looking at the number of sunspots that have been visible since the beginning of last year. Now, sunspots are an indication of the amount of energy that the sun's putting out. So I'm going to have a look at the ISES solar cycle F 10.7 centimetre radial flux progression. When there are very few or zero sunspots on the surface of the sun, then it follows that the radial flux lowers also, i.e. the amount of energy output of the sun lowers very slightly. But this, I believe, does not have much of an effect on the Earth's climate on its own. Nothing at all, really. But during periods of low solar activity, then more cosmic rays and particles are allowed to enter the Earth's atmosphere. As more cosmic radiation comes into the atmosphere, then that allows more free radicals to be created, which in turn go on to destroy methane molecules. A process I believe is amplified during solar minimum. Now this presentation is all about comparisons. So what I've done is I've looked at the figures for the radial flux, the actual strength of the sun. For example, I've looked at let's pick on August 2019. We had a flux of 67.1, and in August this year we had a flux of 71.7, and I've done a comparison for each month for this year compared to last year. So here I've put all the figures in a table. Here's August. It was 4.6 higher this year than the previous year, and I've done that for each month. And then I've taken a 3-month average. So I've took an average of January, February, March, and got an average of minus 0.1, and I've done that for each 3 months, and plotted a graph, and it shows that over time, since January, the flux of the sun decreased during late winter, early spring, and now as the sun is showing signs of life, going into its new cycle, and there's been a few more sunspots appearing, the flux has been increasing in recent months. So what does it all mean? This is the graph I showed you earlier, showing the methane concentrations this year compared to last year. And this is the more recent graph I showed you, comparing the solar flux levels this year compared to last year. And as you can see, earlier on in the year, the solar flux was weaker than it was last year, when there was hardly any sunspots at all. But now we're slowly coming out of the solar minimum. The solar flux is picking up, and it's now higher than it was this time last year. So what do you think is going to happen when I superimpose one graph on top of the other? Well, let's move the graph up. And as you can see, that's not a bad fit. So when there's not many sunspots, that allows the cosmic radiation to penetrate and leads to the destruction of a lot of methane in the atmosphere, keeping the concentrations lower in comparison to the previous year. But now, as solar activity has increased, and therefore the solar wind has become more powerful, there are less cosmic particles entering the atmosphere, and methane levels have risen and are now much higher than they were at this point last year. That's just a slam dunk. I'm going to use this tool I've developed to watch out for any unusual methane outbursts. It may provide early warning signs of excessive methane being released into the atmosphere. I shall continue to monitor the methane concentrations in conjunction now with solar activity. I hope I've managed to convey clearly my theory that low solar activity aids in the destruction of methane in the atmosphere and thus causing cooling effects on the planet. It's going to take a record grand solar minimum to help remove all the methane that's already built up since pre-industrial times. So I don't think grand solar minimum would have any noticeable effect anyway on the planet. But what you've got to watch out for is that if we come out of grand solar minimum and go back up to anything like a normal solar cycle, then less and less methane, more and more methane's going to survive in the atmosphere. And we could see levels rise quite sharply. In my humble opinion, methane levels should be reducing, coming down at the moment during such a deep solar minimum, and yet they still keep rising. So there must be a lot of it coming up from somewhere. And with that, I'll say thanks for coming. Goodbye.